So again, for this example, we're going to use substitution, and we're looking for what can u be equal to, so that when we divide by its derivative, we cancel with a function. Well, I've spotted that the derivative of cot x is minus cosec squared x. So if I let u be 2 plus cot x, I know that when I divide by the derivative of u, we're going to cancel with the cosec squared x. And I've let u be the whole of this thing inside the bracket, because that's going to make sure that I've got a really simple denominator, which is u cubed. And remember, 2 isn't going to affect my derivative, so I might as well let u be the whole of 2x plus cot x. So our integral is going to become cosec squared x. I'm going to leave that as it is, and on the bottom I'm going to have u cubed dx. So if we work out du by dx is going to be cot differentiates, careful we're differentiating now, cot differentiates to minus cosec squared x, and you can find that in your formula book. So we're going to rearrange this to get dx on its own. Perhaps I'll do it in 2 steps because it's a negative. So we're going to have du equals minus cosec squared x dx, and then divide by cosec minus cosec squared x to get dx equals minus 1 over cosec squared x du. So we can change this into a du integral, because we're going to have cosec squared x on the numerator, u cubed on the denominator, and then we're going to times by minus 1 over cosec squared x du. Okay, so the reason why this works is because we chose u, so that we're going to divide by its derivative, and we're going to cancel the cosec squared x. So at this point, I'm going to take, I'm going to write this as, so we've basically got the integral of minus 1 over u cubed du. And in order to integrate this, we're going to write 1 over u cubed as u to the minus 3. And then we can just use normal polynomial integration. So we're going to increase the power by 1 to get u to the minus 2, and then we're going to divide by the new power. So we could actually write that as a half u to the minus 2. And we need to go back to x, so we're going to replace u with 2 plus cot x. And it's a good idea to check that if you differentiate this, you get the function that we were integrating, which we do.